let's go to the one last question we got, which is from Jay in Discord asking, let me just paste this message into Neonym. So the question was, I am modeling a protocol URI string with effect schema. It's a string composed from smaller schemas. There's a scheme, and then part A, and then an optional / part B, and then an optional / part C, etc. Each part already has its own schema. Some parts normalize on decode. The current approach is at URI from string is a codec from string to a structured value. At URI is a union of valid structured shapes, part A, part A, part B, part A, part B, part C. Parsing uses the template literal parser and then transforms parsed parts into the structure. Is this idiomatic effect schema shape for a public API? Alternatives we're considering branded string only with parsing separate, one struct with optional fields, schema.class, data.class, custom parser transform. Let's look at the implementation. We have a union of the different valid template literals. So this is the parser. We've got a codec, which goes from at URI to at URI encoded. I think this type, this is fine. It just, so this looks fine. One thing to be aware of is that when you do annotate types with schema v4, you lose. So schema v4 has 14 generic type parameters. When you annotate a type, you lose all of that extra information. That being said, I tend to annotate my types if I know I don't need any other information other than, like, for example, what's in the codec here. So it's a trade-off, right? If you don't annotate your types, TypeScript has to do more work to infer them. And schema does have a lot of generic type parameters, but you do lose some information. So just things to be aware of. Okay. I think you can brand this. No, maybe you can't. No, it's a union.
I would say something maybe more drastic.
Okay.
I would say that probably if you look at the implementation, basically we have 3 different patterns for a new URL, and we have like 3 different objects that matches like those 3 patterns, and then we have in the end a transform that converts the union of the first 3 to the object of the 3 that you can get. I would say that probably what I would do, that's up for discussion, but what I would do is instead of doing the manual transformation in the end, what I would do is already define the entire at URI from string as an union where each member is a template string literal that converts to that specific structure. So that way I don't have to manually define the transformation, because given the union's attempt to first pick the first member, and if that conversion fails, that bubbles up down to the other ones. If we have probably a union with the 3 members, with the first one being like the most complete one, probably we can get a way of having this schema that basically takes a string and returns, which is the URI, and returns that structured object in one go without having to fiddle with manual transformation. Not sure if it would work, but that's my way how I would think about it.
No, it's a good call out. I kind of agree. Mattia's got an interesting idea there, where instead of having like the separate union for the parser, the URI, and then the conversion, what if you just define a schema union where each element defines its own transform? And then you could potentially extract like common pieces of logic from the transform. I mean, this is fine. Like all of this is fine. Nothing here looked crazy to me. But yeah, that's another potential way that could simplify this a bit, is defining transforms for each one of these. And then, you could have separate schemas for each one that you union together. Might just make things a little bit. I think I follow what you're saying, but I might need an example of what that might look like. Having a hard time visualizing. It would literally just basically be like extracting this template literal parser, this template literal parser, and this one, and then defining the transform attached to each of them into your final data structure. So you would have a transform from this to this, a schema that is a transform from this to this, and a schema that is a transform from this to this, and then you would union them together to get your final at URI from string schema, instead of having this union, and then also having this transform method, because then you could define the logic for
the logic
each.
becomes trivial, basically, because you are just mapping position 0 becomes an object with authority. Always, there is no condition of the length or whatever. You are just saying, if we match the last entry, we just take the matched entry and becomes an object that has just the authority key, and the value becomes that entry.
Yeah,
and so you don't have that.
Yeah. We don't have these checks. We don't have all this conditional logic, and you could extract the getters as well, like into individual methods. So like you could basically define. So in schema, in effects in v4, if we go to scheme, actually let me just do this in U of M. It'll be easier. Schema transformation, you'll notice that we tend to extract common transforms into shared. Wow, there's a lot of types in here. Hang on. Let's just look for big int string. So you'll notice here that you can extract transformations like into a shared variable that can be reused. So you could even do this, right? You could clean up the actual definition of the decode to even further. So every single case becomes a full spec from string to structured object, and then you just union them together. It might not work as well as we think in our minds. Like we'd actually have to like implement it to see, but yeah, like it could be a way to clean things up a little bit.
It is something that in my mind makes like more sense about how you reason, because then you basically collocate the encoded and the decoded shape together, because you see the object that you produce with the template you have basically in the same piece of code. Whereas doing that as you are doing now, you are basically having all of the encoded, all of the decoded, and then the transformation, which again probably is fine with only 3 cases, but if eventually you need to support like 5 or 10, that probably become more messier.